Today we're here at Murph. Murph stands for the Midwest Rep Rap Festival. What this is all about is Rep Rap printers, people with their own printers, CR10s, any type of printer. They're here to show this stuff off, and we got a couple interviews with some of the most interesting printers I've seen so far in the show. So without further ado, let's get on with the show. So I'm here right now with Walter, who's has an interesting idea. He actually 3D printed a 3D printer. Is that correct?
That would be correct.
And what type of printer hardware did you use on this to get this printed?
Well, when I first started, it started off as the ANET A8 upgrade to the AM8. But the AM8 was the aluminum extrusions, and it was like $80-something for a kit. And I'm like, I think I can 3D print that for cheaper. So about $25 worth of filament, and 5 days later, I had some extrusions. But I have to say, it might be a record on an ANET A8. It was 112 hours straight print.
Wow. So you've actually run this. How many hours would you say now that you've run this printer now for?
Yeah, I couldn't tell you because it's probably 5 months. Oh no, about 3 months old.
Okay.
And all three of my printers in my house run probably constantly. So for 3 months, this has been running constantly until about a week ago when I took it down. I was going to make some improvements, before Murph. Yeah.
Yeah, I know those improvements. They never happen. Or you go to shut down and you can't.
I turned a 1 hour live stream for the improvements into a 5 hour live stream that ended with some cussing.
So on the system alone, what are you running as hardware, as hardware goes?
Well, right now I've got a mini Rambo board. It's a 30 amp power supply, some generic NEMA 17s. This is a BQ extruder, the mechanism, and some ANET rods that I got. This was a 400 millimeter rod, and I thought I was going to have to cut it to make it fit the printer. Well, then after I'm like, you didn't need to cut it, so I've got a 400 and a 380. But most of the hardware is just really generic stuff, minus the Rambo board. I didn't skimp on that.
What about the plate? The plate is also
it's the ANET plate. Now the carriage is not. It's a $15, $20 plate off Amazon again.
Okay.
But the bed I had laying around was I had a couple ANET beds because you buy extra parts when you buy that printer. So I had a couple of those. That's what I used.
And what about the bed itself? Like, what are you using for your build tech?
Again, it's a generic, polycarbonate plate.
Okay.
And the reason I was stuck with these because I tried several before, and you know how hard that glue is to get off when you have to change them. You burn a hole in it or whatever. The glue comes really off with these. I mean, it's pretty much clean when you get done, when you take it off. And out of 9 that I've bought, because they come in a 3-pack, only one of them has not stuck at up to 100 degrees. At 100 degrees, it was starting to peel off by itself. So, only one bad, not too bad.
Yeah, I'm just impressed with the design and everything else that you were able to print the extrusions with a regular everyday with your 3D printer.
And I think with the new one that I built, I could actually build it stronger because this is a 85% infill PLA, and it's got three shells on it. I think I could do it with 2 shells and 85% if I could print them in one piece, because these are just super glued together. There's no internal structure. There's no nothing. It's just super glue and plastic.
Yeah, I was going to ask you about that too.
Yeah, but so I stole your thunder. Sorry, but
okay.
You can tell that I ran out of the regular PLA, and I had to go with the semi-transparent stuff to finish because I ran out. It took a whole roll and just a little piece, but I used the 3D Solutex. It's like $18 a roll or so. So pretty cheap frame.
Yeah, I'm actually very impressed. Thank you so much for showing it to me.
Not a problem. Appreciate you talking to me about it.
Yep. Hi, once again, I'm here at Murph, and I ran into Tom here from Tom. So, how are you loving this today?
Holy man, this is such an amazing event. Like, we don't have this sort of thing in Europe. Just seeing all the people that are making things happen behind the scenes, it's so awesome.
And what do you see, coming out, after being here, I know this is our 3rd day here right now, what have you seen anything here that really impresses you?
That question, I mean, I've asked other people that question, what is the most impressive thing? And I don't think I can pinpoint one single entity. Yeah, there's the glitter printer over there. There's the huge delta from CME CNC. But it's really it's more abstract. Like it's people coming together, working together, sharing their love for the same thing, and just seeing that. That is probably the most impressive thing that I've seen here.
I found one of the printers I was looking at, the guy that did the 3D printed extrusions himself.
Yeah, that's core rep. That's what it's all about, right? You know, you take out as many parts as you can, and you make them yourself.
So, not to say anything wrong, but have you, just to let people know what your channel is, and point them in the right direction.
Yeah, most people just know me as Tom, but youtube.com/Thomas Sanadra. Just put in any YouTube video search query into YouTube. You're going to find me.
Well, thank you so much for allowing us to talk, and have fun at the show.
Yeah, thanks, man. Enjoy it.
You too. I'm here at Murph also with Bill here, who has some very interesting printers that I think everyone should see. So, Bill, can you tell me a little bit about this printer right here?
Yeah, this is the PrinterBot printer belt. Brooke Drumm and I came up with this last year at Murph. That was I actually was showing off a belt printer that I had, just a prototype that I designed, and after the show last year, I kind of convinced Brooke that he should build one. So this is the very first prototype of that machine. I run it continuously, and you can see here I've got many parts on it. It just continuously produces parts one after the other. Kind of works in an interesting way. It's not Cartesian per se. It's X, Y, and Z Cartesian. I call it X, Y, Z prime, because the Z is actually the belt. And so it actually, the parts just move down as they get taller. They're moving forward, and eventually they fall off.
And how about part cooling now? Does it cool as it move it across?
Yeah. So the build plate actually is heated only halfway, and the parts are actually stuck extremely well to this stainless steel belt. And so we actually have to allow it to cool down before it comes to the end of it. So the belt's heated halfway, and then it's allowed to cool down to 45 Celsius at the end, where the arch actually allows it to release the curve of the belt. And the belt, they'll just pop right off. In fact, it's not even attached there. So by the time they get down here, they come right off.
That's one interesting way to do your prints. Yeah. And you say you had a $23 printer?
So what's interesting about this is I've been working on this design exercise to see how cheap can I make a printer. The Tico was like $139. The Start is like $99. So they just keep getting cheaper and cheaper and cheaper. I thought, well, just how low can you possibly go with this? So I built this machine, and every piece on here is brand new. It's running an Uno with the CNC shield, 4 controllers. So it's got a hacked firmware on it to drive 4 stepper motors. I've got these little 79-cent 24 BYJ motors on here, all of them. The build surface is actually a cookie sheet, and it's actually driven by 2 of these motors with friction feeds. It rides back and forth on bearings, several printed components, but the entire bill of materials on this printer is $23. It's a paste extruder, so it actually has a syringe that it actually uses to pump it. That's about the cheapest you can get. So there's less than $1 in all the parts from that. And then the extruder itself is actually all medical grade components. And can easily be swapped out. So again, less than $1 for all of this. So makes it really cheap. I run things like chocolate frosting, caramel frostings, and fondant, and cookie icing. There's all kinds of things. You can make cookies, take the whole tray, just put it right in the oven. So very, very inexpensive 3D printer.
And you're also saying that with the wheels that you've you can hold it right side up and it won't fall out?
Yeah, so, the interesting thing about this is the build tray is actually held in. It's sitting on rollers, but it's held in by these nylon or these Ninja Flex rollers. So if I pull the rollers off, you'll see that this thing actually just glides right back and forth along that. So these little Ninja Flex rollers are the friction wheels that actually hold the build plate, and that's your Y-axis. So about the cheapest build plate I've ever seen. There's 4 for $1. 4 for $1.
Oh, it's an amazing device, honestly, I must admit. Well, thank you so much. I do appreciate it, Bill, for showing off this stuff, and you have yourself fun at Murph still.
You too. Have a good one.
So today I've just bumped into Purusha from Joe Purusha, which is from Purusha USA Research. Sorry, I'm a little nervous. You're like the star of everything.
Purusha Research.
Purusha Research.
Hi.
And can you tell me a little bit about? Now you guys have come out with the MK3, which is the flexible bed and the powder coating. And how is it like? It's just such an amazing printer.
Well, thank you. So, usually the best inventions and best creations come from solving your own needs. So we have a large print farm. So we added a lot of features to make it easier and quicker to use. And, that makes the features, complete and thought out completely. So I guess actually people appreciate it too.
Yeah, it's all open source too, correct?
Yes.
One other thing, what has been the printer that's been really inspiring you today that you've seen so far?
I didn't get a chance to go through it completely yet. So you just stopped me on my way.
Okay, well, I'll let you continue on with the show. Thank you so much. I do enjoy your printers and everything else that you do. Thanks.
Bye.
Thank you for tuning in. I'm here with Brian, who's at Murph right now, and he's built a couple of rockets here, so thought I'd bring him on and talk about it. So how does this all become, to build the rockets and everything else?
So we ran into the marketing problem. It was going to take 4 to 6 years to get into orbit with the payload we developed. So as my 5-year-old daughter said, sounds like we need to build a rocket. So we started building these PLA plastics and testing some rocket engines. And eventually we found out that the ceramic heat coating we're using will actually allow us to fly a piece of PLA. This nozzle's been fired at 2200 degrees, about 2000 psi, and for about 3 seconds. And you can see it's still in good shape out of the PLA plastic. So we're actually going to be flying something this size this summer. This is going to be bringing in about hypersonic. We're going to take it up to 100,000 feet on a weather balloon and then fire the rocket from there. We'll go to about 4,000 miles an hour and about 750,000 feet. So we'll be in space with Kármán line at this point. We've been doing this for about 3 years. We've been a company for about 3 years. We've been on this project for 5. I've had my 5-year-old daughter. She's now 12. She took 5th in the world as a new space leader at 12 years old. So we really involve the kids in it because really they are my market. Okay, 35, 40-year-olds, us, we're too old. By the time this is running, we're going to be using the 12, 14-year-old kids are going to be doing experiments with this.
It's amazing what you can do now with 3D printing and how far it's come along. And you said that the glaze you said that you use is fire retardant, is that correct?
It's a endothermic ceramic composite. So what we do is we actually spray it onto the nozzle and the PLA plastic absorbs it into the plastic. So this is no longer plastic, this is all ceramic now. It's a proprietary formula that we've developed over the last couple of years, and we're going to fly plastic. So I've got a rocket motor now that has no metal in it. It's all plastic.
Wow, that's amazing. And you said that you were ahead of MIT, is that correct? Or
MIT's been doing the same project in the last year. I was a medical engineer in the MRI field, ultrasound, MRI, nuclear med, and I basically got divorced and got sick of doing that work. So built a satellite, ran into this launcher problem. It was going to cost me 2 years and $4 million to get my satellite in orbit, and that's when we decided to do a rocket on our own. And if you don't have your own rocket, you're never going to control your own space company, because you got to get off the Earth first.
Well, thank you so much for taking the time, and have fun at Murph. I'm here still at Murph, and I ran into these people at Art 3. Look at this printer. It's about the size I am. And we have right here Jacob, who's sitting on it.
How you doing?
So, Jacob, tell me a little bit about this printer so that people can understand, what is this?
So this is a internal prototype for a machine we're developing for a company in Indianapolis. So it is our first attempt at making a large format machine. So this machine right now has a build volume of roughly 13.5 inches by 17 inches by 24 inches in the Z. We're using ClearPath DC servos instead of stepper motors. So total closed loop system, Duet Wi-Fi with a DuX5 expansion board. We're working on a 6 tool head changer with 1 tool head being a Z-probe, 2 Bowden tool heads, and then 3 more direct drives with all different nozzle sizes and configurations for different materials. So.
And how did this become designed? Like, how long did it take you guys to figure out what type of metal to use? How did this all come together?
So this came together in about 2.5 months. Actually, this particular revision came together in about 5 weeks. So our original plan, we were really ambitious and wanted to build a 0.5 meter by half meter machine. And then when we realized that would weigh like 0.5 ton with just like the build plate, and we realized how expensive it'd be, we're like, we don't have enough money on their credit card to do that. So mid-February, like really late February, when we were going to like start to purchase things, we're like, we can't do this. We gotta scale down. So we figured out the rough dimensions we'd need of the 8080 stuff, ordered it real quick, and then everything was design as you go from there for 5 straight weeks. My other partner in crime with building this, Daniel Halverson, he lives in Minnesota, and he came down on his spring break at the first week of March, and we just went crazy trying to put this thing together. And since then, it's been 3 solid weeks of late nights on Facebook Video Messenger, catting away and like, measure this, measure that, because he's got components and I've got components, and it was just amazing how all this came together, and we developed a workflow that went pretty seamlessly. Like, in terms of iterations, there were only like 2 times out of the many parts we went through where we really messed something up. So it's been beautiful.
And also, you were telling me you are legally blind. Is that correct?
Yes. So my day job, I work at the Indiana School for the Blind and Visually Impaired in Indianapolis. I run a fab lab there, and my job is to design tactile models for teachers to use in the classroom. And then I teach students that have a little bit of usable vision how to do CAD modeling and run printers. And then we've come up with a workflow where my totally blind students can run a laser cutter. So I graduated from the School for the Blind in 2012, went on a crazy learning adventure for 3 or 4 years, and came back and was like, this printing stuff, we need to do this there. And they gave me a chance at it. We ended up raising a lot of money and built an awesome lab. So
I'm just looking at this machine and all the parts that go in it, like the power supply itself, the driver motors. It's just insane.
These power supplies are El Cheapo power supplies, and they're gonna get it done to get it to work. We're gonna have to buy real power supplies where they're like $200 a piece.
And how much weight would you say that this can support?
Well, yesterday afternoon, me and Daniel were sitting on top of this, and our combined weight was like 370 pounds. So the machine itself weighs 200, so we're doing good. 170 over.
That's impressive. Well, thank you so much, and hopefully, this was the prize, really, to see this thing see that in the show.
We had a hard push to try and get it done by Murph, but we had some electrical problems that we encountered, and we were like, well, what do we do? It's like 6 a.m. on Saturday morning. Like, what's the backup plan? We're like, we're going to make it look pretty and just take it and see what happens. Because we were kind of scared to bring an incomplete machine. But then it's like, bringing an incomplete machine turned out to not be a problem at all. Like, my biggest suggestion for people that come to Murph, and if you're afraid that, like, oh, my machine doesn't work yet or whatever, and people are going to criticize you and not respect your stuff, like, bring your stuff in progress, because it is so cool. And there's so much knowledge here. Like, we have some issues with wiring the servos to the Duet board where we need a voltage step up, and we weren't totally sure how to do it. We tried some step up circuits, and a guy walked by an hour ago and we were talking to him. He's like, oh, there's this $3 board on SparkFun. you buy that, wire it up like this, it'll solve all your problems. We're just like, whoa. It's amazing how helpful the community can be. So,
Well, thank you so much. I do appreciate it once again.
find us on Twitter